Section 10.3 is our section on polygons. I'll be a little less wordy on this. I think you can read the section and with the short explanation I give, hopefully be okay on this section. When we talk about poly means many. Polygons are shapes with many sides. So we can have shapes with 3 sides or 4 sides or 5. There's 6, there's 8. I skipped over 7. We know that triangles have 3 sides. If we have an object that has 4 sides, we call that a quadrilateral. Usually I can say it. Quad means 4 sides. An object with 5 sides is a pentagon. 6 sides is a hexagon. 8 sides, of course, there's our stop sign. There's an octagon. Something I can't spell today, octagon. All of these, not all of them, but all but these 2 are regular polygons, meaning the sides have the same length. All 6 of these sides have the same length. With a square, quadrilateral, that has the same length on all 4 sides, is a square. This is a pentagon, it's regular, all 5 sides are the same, or all 8 sides here. Notice on my rectangle, 2 sides are longer, and the triangle is not an equilateral triangle. But polygons can be any closed shape with however many sides you want to have. Pretend that's closed. There's a polygon right there. Now, certain polygons have fall into different categories, just like triangles could have more than one different name. A parallelogram means that both sets of sides are parallel. So the top is parallel to the bottom, and the left is parallel to the right. Does not mean we have to have right angles, as in a square or a rectangle. It can be tipped over on its side. And your book gives you some other examples of regular parallelograms. Also, the rhombus is one I didn't draw. With a trapezoid, 2 sides are parallel to each other, and then the other ones are not. Okay, these go in opposite directions, so they can't be parallel. Here, the top and the bottom are parallel to each other, but the sides most obviously are not. Those are called trapezoids. Notice all of these are quadrilaterals. All of them have 4 sides, 4-sided objects. When I talk about finding the perimeter of an object, it means we're supposed to add up the sides. And that's really all there is to it. If it's a triangle, I add up 3 sides. If I have a hexagon, I'm going to add up 6 sides. If I have some kind of a strange shape, maybe I'm making a fence around my yard and part of my house, but not all of it. Maybe that's what I want to put fence around. Then I would add up 1, 2, 3, 4, 5, 6 sides there. But perimeter means add up all the sides. If we want to know the angles of the inside of a polygon, we know already that the sum of the angles in a triangle are 180 degrees. Now, if we want to add up all of the angles inside a square or a rectangle, what I have here are 4 90-degree angles. And if I take 90 degrees and add it up 4 times, I get 360 degrees. Any quadrilateral, it doesn't have to be right angles in the corners, but anything with 4 sides, the inside angles are going to add up to be 360 degrees. In general, if n, the letter n, is the number of sides of your polygon, so here I have 5 in my pentagon. If I take 5 minus 2 and multiply that answer times 180 degrees, that tells me what the sum of the interior angles is going to add up to be. So if we take 3 times 180, we should get 540 degrees. If I add up all 5 of these angles, okay, whether it's regular or not, all 5 of those angles added up should be 540 degrees. So in general, what you're after is n minus 2. That quantity times 180 degrees, that tells you what the sum of all of the inside angles should add up to be. and it's different for every shape. The more interior angles you have, the bigger that sum is going to be. Now, your book also talks about tessellations. Tessellations are not something that I could even begin to draw on here if I wanted to, but it's something that's kind of fun to look at, something I'm sure you've seen before. It's also called tiling sometimes, and so you'll need to read in the book about how that works, and look at the pictures because they're kind of fun to see. I will email you the assignments for sections 10.2 and 10.3 so that you'll know what section or what exercises you'll need to work on while I'm gone. But this sums up the video for this section.